Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Omar Temimi bin Sheikh Farid. So, my group and I gonna present about force, Newton's third law of motion. Our group member is Vimanan E2021202927 myself Omar Temimi E2021202927 and Aldevins E20212029 Our lecturer name is Dr. Rosali bin Ramli. So, for the introduction, the Newton third law states that all force between two objects exists in equal magnitude and opposite direction. If one object A exerts a force Fa on a second object B, then B simultaneously exerts a force Fb on A, and the two forces are equal in magnitude and opposite in direction, which is Fa equal to minus Fb. The third law means that all forces are interactions between different bodies or different regions within one body, and thus that there is no such thing as a force that is not accompanied by an equal and opposite force. In some situations, the magnitude and direction of the force are determined entirely by one of the two bodies, say body A. The force exerted by body A on body B is called the action, and the force exerted by body B on body A is called the reaction. This law is sometimes referred to as the action-reaction law, with Fa called the action and Fb the reaction. In other situations, the magnitude and direction of the force are determined jointly by both bodies. It isn't necessary to identify one force as the action and the other as the reaction. The action and the reaction are simultaneously, and it doesn't even matter which is called the action and which is called reaction. Both forces are part of single interaction, and neither force exists without the other. The two forces in Newton's third law are of the same type. For example, if the rod exerts a forward frictional force on an accelerating car tires, there is also a frictional force that Newton's third law predicts for the tires pushing backward on the road. From a conceptual standpoint, Newton's third law is seen when a person walks. They push against the floor and the floor pushes against the person. So that's how a person can walk. Similarly, the tires of a car push against the road, while the road pushes back on the tires, and the tire and road simultaneously push against each other. In swimming, a person interacts with the water, pushing the water backward, while the water simultaneously push the person forward. Both the person and the water push against each other. The reaction force account for the motion in these examples. These forces depend on friction. A person or car on ice, for example, may be unable to exert the action force to produce the needed reaction force. Newton used the third law to derive the law of conservation of momentum. From a deeper perspective, however, conservation of momentum is the more fundamental idea derived via Noether's theorem from Galilean invariance and hold in cases which Newton's third law appears to fail. For instance, when force field as well as particles carry momentum and in quantum mechanics.
Hello everyone, my name is Eldamin Shanis, and today I wanted to present about the objectives, the apparatus, and the methods of the Newton third law experiment. For the first objective is to be able to identify action-reaction force pairs, and the second one is be able to explain Newton's, and lastly is to investigate the relationship between the size of the balloon and the distance traveled on the track. For the apparatus of the experiment, you will need two straws, one balloon, a pair of scissors, a tape, four bottle caps, one empty cans, strings, and lastly a meter ruler. Total of 9 methods that involve in this experiment, which the first is to make the body of the card of the empty can for the balloon card. Second step is the bottle caps are punch holes by using the scissors, which then acts as the wheel for the card. The third part is to attach the wheels at the end of the straws, as it acts as an axle. Fourth, by using tape to secure it. The fifth step is to blow up the balloon as large as it will go and do not bind it. The sixth step, with the length of the string. Then wrap the string around the balloon to get the circumference measurement. Record this on your table. The seventh step is to pull the balloon to one side of the string and either tie it to something or have a friend to hold it. Allow your balloon to open and fly around the track. The eighth step, using the meter stick, calculate the distance traveled and enter it to your data table. The final and the last step is to repeat the step 5 to 8 by using the other balloons but in a smaller size.
Hi, my name is Vimanan and next we'll see the results. Length of balloon. First we measured 27.7 cm balloon. The displacement of the balloon was 62.5 cm. Next 21.3 cm. Its displacement was 55.3 cm. Lastly we measured 18.1 cm balloon. Its displacement was 49.8 cm. Discussion. Newton's third law of motion states that if object A exerts a force on object B, then object B will exert an equal but opposite force on object A. In other words, to every action there is an equal but opposite reaction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it also applies to bodies in uniform or accelerated motion. The forces it describes are real ones, not mere bookkeeping devices. In this experiment, the principle used in balloon cart is explained by Newton's third law of motion. The action that pushes the air out of the lip of balloon results in a forward force, also known as reaction force, that propels the balloon cart forward. In the balloon cart, forces act on the cart in the system. In this case, the force of air resistance pushes back against the thrust of the balloon. When you change any variable in the system, the outcome will be affected in some way, whether the acceleration of the balloon, its terminal velocity, or its time of acceleration is changed is not known until the system is observed. In this experiment, the amount of air in the balloon was manipulated. The higher amount of air pushes the cart further than the smaller size balloon, which has lower amount of air. Conclusion: the bigger the size of balloon, the further the displacement of balloon cart. That's it from us. Thank you very much for listening.